everybody. Video number 2, or a vocabulary for organic. We got 20 words. We need to know them. Here is your learning target for this lesson. Be able to define our vocabulary. So first one, homologous series. Homo means same. So table Q is the homologous series of hydrocarbons. Notice they're kind of similar. They'll have carbon and hydrogen. This is a group of hydrocarbons. Don't let that word hydrocarbon fool you. That's hydrogen and carbon. Hydrocarbons with similar chemical formulas. These are table Q. Okay, homologous series. Organic prefixes, table P. As a matter of fact, we're going to go through the 3 reference tables that this defines this whole unit. We need these 3 things. Okay, so organic prefixes. These are the words that tell us how many carbons form the backbone of the molecule. Table P. Okay. Functional groups, table R. If you see this, now you can see why it's going to take me 20 minutes to go through examples of every one of these things forwards and backwards. Oh my good Lord, that one's going to be a long video. Sorry about your luck. This is the part of the molecule that makes it different from plain hydrocarbons. Let me rephrase. That is the part of the molecule that makes it different from just plain hydrogen and carbon. Hydrocarbons, hydrogen and carbon. Please make sure we have that connection made. These classifications based on the placement of O or N. Sometimes it's a halide, like bromine, chlorine, iodine. Okay, these are all on table R. Alkanes, the simplest of the hydrocarbons and the first ones that we will study. Okay, these are hydrocarbons that contain all single bonds between the carbons. And in which table was it? With the homologous series, table Q, you'll see the word alkanes and you'll see the picture. It has single bonds, so you can make that connection here. Pass your vocab quiz quick. Okay. After that, we have alkenes, also on table Q. Notice they have something different. They have a double bond, so one letter changes everything. I changed the A in alkanes to E to make it alkenes, and now I have a double bond. Okay. Again, clue in table Q, so you can do this easily. Alkynes. Oh, here we go. Sorry, picture. Notice a little bit different. I now have at least one triple bond. I can have more. Why is it going so fast? Alkynes, hydrocarbons that contain at least one triple bond. So if I take that E and I change it to a Y, now there's a triple bond. So I know I've said this a few times. When you get to organic, you'll see one letter makes all the difference. It's med specific. So you need to understand what those are. Table Q is your hint. We will learn to use it forwards and backwards. Single push. Go. Structural formula. So notice this shows me the elements and their orientation in space. This is called a structural formula. So this is a diagram representing the number and arrangement of atoms. Structural formula. That arrangement of atoms is given. It's basically the picture, and we need to be able to draw those. Making that picture is what you're going to be able to do. Molecular formula is a little bit different. Molecular is just what we're used to. The atom and the number preceding it is a subscript. So C6H12O6 is a molecular formula. We'll be able to have to make those. This is the symbol that shows how many of each element in the molecule. Notice it does not show me the arrangement. The arrangement comes from the picture, and I can count up however many atoms and get the number that way. Okay. Molecular formula, just how many. Isomers. Isomers, same but different. So if you counted here, you would see the same number of H's, same number of O's, and what the picture just doesn't show you is every time the line crosses, there's the carbon. So at every T in the lines is a carbon. And so there's the same number of carbons too. So same number of every atom, different arrangement in space, hence different functions. Okay. So 2 molecules that have the same number of each atom, but different arrangement in space. Straight chain hydrocarbon. So this is a straight chain hydrocarbon. You'll learn how to get to that word hexane. Notice the carbons are all in a straight line. This is as simple as it gets. So this is a simple hydrocarbon chain that has no side chains or functional groups. Okay. A branched hydrocarbon is basically a side chain with a branch, literally. We'll get into the rules of how to name these things. I know it looks very complex, but once you get the feel for how to break those words down, I'm going to do it backwards every time. You can figure out what's what. I promise. You'll get this. Branched hydrocarbon. A hydrocarbon that has one or more carbons attached to the side of the chain. It's not just a straight chain. It's slightly more complex. Okay. A saturated hydrocarbon, this is going to come up big. Notice that all the carbons have as many 4 bonds as they can, holding as many hydrogens as they can. So every carbon will have 4 bonds. The question is it filled up with hydrogen or not? Or have I created a parking spot because there's double bonds? So the saturated hydrocarbon has as many hydrogens as it can. It's the alkanes, and if you want to put a side note there, it's because it's single bonded. The carbons have single bonds between them, hence I can put the maximum number of hydrogens around. You'll see with unsaturated, that's not the case. So I'm guessing that unsaturated is next. Unsaturated, ready? This has now, you see, a double bond or a triple bond, and if that was 2 carbons with a single bond, the alkane, it would have 6 hydrogens. Notice it only has 4. So it's not holding as many as it can. It has some empty parking spots, if you will. I could break that double bond and put a hydrogen on the bottom and a hydrogen on the bottom and make that ethene, ethane. And the number of hydrogens changes. So this is unsaturated. Any double or triple bond, it's unsaturated. So it's not holding as many hydrogens as it can. These are all of the alkenes and alkynes, any double or triple bond. Now we're going to get right into some of the reactions. So start off the unit with some of the reactions. We'll end the unit with the reactions. Polymerization. Notice there's many of the same thing. This is a reaction that links many monomers together to make a large chain. So a monomer is any one single piece that is repeated over and over and over again. Kodak was really good at making polymerization reactions. Fermentation. This is the creation of alcohol. So a reaction where an enzyme reacts with sugar to make alcohol. So alcohol will be the key product in any fermentation reaction, and probably carbon dioxide too. The best reaction of all, if you ask me personally, combustion. This will always, always, always make carbon dioxide and water as a product. I will need oxygen in any of the hydrocarbons as a fuel, as a reactant. But oxygen, carbon dioxide, and H2O are the keys. It'd be O2 for oxygen, CO2 for carbon dioxide, H2O for water. If you have carbon dioxide and water as a product, hydrogen present as a reactant, it is a combustion reaction. Right. And are we done? We got some more. Oh, we got some more reactions. Saponification makes soap. Number 1 rule about Fight Club is we don't talk about Fight Club. Reaction where the base reacts with fat to make soap. So saponification makes soap. I don't know how you get that from saponification to soap, but you can. They both start with S. Esterification is going to make an ester. You don't know what an ester is yet, but we will get there. We have to figure out what those are with the functional groups. Once you figure out what an ester is, you can understand that I have an organic acid reacts with an alcohol to make an ester. If I make an ester, it's esterification. Substitution reactions. These are 2 reactions that we need to be able to differentiate. So this picture is a perfect substitution reaction where the Cl in the diatomic Cl and one of the H's in the methane switch, and there's a straight substitution. Okay, and in order to have that happen, you have to have all single bonds in the hydrocarbon. So boom, 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 switches. Okay, good, you got that, read that. And then the addition reaction is very similar, except for there is a double bond on the molecule. So if I break that, I can literally just add in the halogens. I don't have to switch them out. So in an addition reaction, there'll only be the one product. It's a reaction where an atom of one molecule is simply added to the atom of another molecule, addition reaction. And with that, I think we are finished. Study up your words. Let's pass that vocabulary test sooner the better. Pretty please and thank you.